All right, so today we're going to talk about factoring trinomials when the leading coefficient is not 1. And there are actually a bunch of ways to factor these types of trinomials. What I'm going to focus on today is the guess and check method. So I will do one quick review of factoring a trinomial where the leading coefficient is 1, okay? Because that's the easier way to do this stuff. And we'll talk about why and how the guess and check method will work here as well. But for the most part, people seem to be okay when we have something like this. Let's see. Okay, a trinomial that looks like this. All right, and pretty much everyone knows that it breaks up into two separate sets of parentheses, and it needs to be x and x, and then you're looking for factors of negative 15 that add up to negative 2. So that would be negative 5 and positive 3. And then typically those factors just go into the parentheses, and you have factored the trinomial. But what you're doing is what I like to call reverse FOIL. So if I were to FOIL this back out again, right, I would get x squared plus 3x minus 5x minus 15. And then you would combine those two like terms in the middle, and you would have your negative 2x. The problem is that this method doesn't work when the leading coefficient is not 1, because you can't just write x and x anymore. Because when we FOIL, we need this to be 3x squared. And that's not going to be 3x squared. So it's a little bit more work. And some people like to change this into 4 terms and do grouping. I find that the fastest and most efficient way to do these are when you use guess and check. And it does require a little bit more thinking, but I find that when the numbers get even larger, guess and check is much easier than rewriting this in 4 terms and doing grouping. So here's how I do the guess and check method. I know this is going to factor out into 2 binomials, 2 sets of parentheses. And I know that the first term in each of these parentheses, when I multiply them together, I have to get 3x squared. And what's nice about the number 3 is that it's prime. So the only way I can get to 3x squared is if I have 3x and x that are being multiplied. All right? And then I have to look at, so let's see, this is all going to be positive here because everything's positive, so I can put that in there. Then for the guess and check method, I look at the last term. I actually skip over the middle guy at the moment. And I say, okay, when I go to fill in this last term in each of the binomials, when I FOIL that, they better multiply to give me positive 4. Okay, so what are my factors of 4? 4 is not a prime number, so I have to think a little bit more. So my factors of 4 are 1 and 4 and 2 and 2. And now here's where the 8 comes into play. I have to just kind of play around with the 3x and the x. And I have to say, what combination of things that are multiplied, when I add them together in the end, would give me this 8x? Because remember, the 8x is formed by combining those like terms. And I'm going to FOIL this out in the end and show you that. And I know that if I multiply, I'm going to use the 2 and 2. If I multiply 3x times 2, I get 6x. And if I multiply x times 2, I get 2x. What does that add up to? Those would be my like terms that I would add together to get to that 8x. Now here's the trick, is that if I want the 3x to multiply by the 2, I need to make sure they're in opposite sets of parentheses. So I just typically crisscross, and that's a group of parentheses, and that's a group of parentheses. This is going to be 3x plus 2 times x plus 2. Now let's refoil that to make sure it works, all right? So I'm going to do that right over here. So if I do my FOIL, my first, outer, inner, last, I get 3x squared. That's first. And then my outers would be 6x. My inners would be 2x. And my lasts are positive 4. And you can see we had the outers and the inners right here. That's what we were trying to figure out, is what can these outers and inners be so that when I combine my like terms, it adds up to 8x. And it's that quick. And you don't always have to do all this checking in the end. Like, it's so much quicker than rewriting these in 4 terms. Let's do another one. Okay, So this one, 6x squared minus 13x minus 5. Once again, I like the number 5 because it's prime. 6 is a little bit trickier because it's not prime. So to get to 6x squared, I'm either multiplying 3x and 2x together, or I'm multiplying 1x and 6x together. Those are the two possibilities. For 5, my only options are 5 and 1. So I'm going to play around here. Okay, and I'm going to intentionally do some things incorrectly here so that we can see how things don't work, because I already see the answer here. So let's say I take 5 and 1 and I put it here, 5 and 1. And I do, okay, 6x times 5 would give me 30x. Well, okay, so this is going to be, let's see, I need 1 to be positive, 1 to be negative. So the bigger one has to be negative. This adds up to negative 29x. So that is obviously not my answer because I need the outers and the inners to add up to negative 13x. Okay, so then maybe I should skip, or I should switch that and put the 5 here and the 1 here. Once again, if I multiply across, I get 5x and 6x, so I want the bigger one to be negative, so this would be negative 6x. And that adds up to negative 1x, so that doesn't work either. So I've determined that 1x and 6x is not the pair that I want to use. I want to use 3 and 2. So I'm going to play around with this. I'm going to say, okay, well, what combination could give me negative 13? So right away I see if I multiply the 3 by negative 5 and the 2 by positive 1, this could work, right? This multiplies to negative 15x. This multiplies to 2x. If I add my outers and my inners together, I get negative 13x, which is exactly what I wanted. So once again, in my parentheses, if I want the 3 and the 5 to multiply, they need to be in opposite sets of parentheses. So one group is going to be 2x minus 5, and the other group is going to be 3x plus 1. And let's just quick check that by using FOIL. So I do my first, outer, inner, last. That'd be 6x squared plus 2x, right? Because I had 6x squared plus 2x minus 15x minus 5. Combine your like terms right here. You get 6x squared minus 13x minus 5, which is exactly what we started with. So let's get rid of these arrows here. This right here is my factored answer. Let's try another one. Now I chose this one intentionally because the 12 and the 15, neither one of them are prime. So we're really going to have to work here. So 12, it could be 1x and 12x. It could be 2x and 6x, or it could be 3x and 4x. All right, now this is about as tricky as they get because then 15 could be 1 and 15, or it could be 3 and 5. We have to figure out what combination we want to do here. So we need our outers and our inners to add up to negative 49x. So right away, I know that both of them are going to be negative because they have to multiply to positive 15. So the only way that's going to happen is if I have negative times a negative. So let's see here. So like what I do is I'm going to take this and I go, okay, well, 12 times 5 is 60. That's too big, right? So I say, okay, 12 times 3 is 36. That's not big enough. All right, I obviously don't want to do 12 times 15. So I'm going to move away from 1x and 12x. I'm going to come over here. If I do 6 times 5, I get 30. Oh, nope, that's still not big enough, right? What if I jumped down here. I think I found it. What if I did the 3 times negative 15? That gives me negative 45x. And the 4 times negative 1, that gives me negative 4x. Altogether adds up to negative 49x. And I very quickly found the right combination that worked. Okay? So if I want the 3 to multiply by the negative 15, the 3x to multiply by the negative 15, I need them to be in opposite parentheses. So one binomial is going to be 4x minus 15. The other binomial is going to be 3x minus 1. And if I wanted to, I could quick check with FOIL. So if I do first, that's 12x squared, outers minus 4x, inners minus 45x, and last will be plus 15. Combine your like terms, and we should have the trinomial that we started with. Let's just take a look, and yes, we do. So here is, I'm going to get rid of these arrows. Here is my final answer. Guess and check is always the way to go, in my opinion. All right, last one, and I chose this one because this has a GCF that we could take out first. So let's see. Very clearly that 11 is a factor of each of those numbers, and they each have an x. So I'm going to take out an 11x, and I would be left with 8x squared plus 10x minus 3. I'm just going to quick check. Yep. Okay. Notice how I'm just checking as I'm working. There's nothing wrong with that. All right, so now the 11x is just going to come down, and I'm going to try to do my guess and check with the remaining trinomial. So 8 could be 8x and 1x, or it could be 2x and 4x. What's nice about the 3 is that my only possibilities are 3 and 1, but one of them is going to be negative. So either be -3 or -1. We'll figure that out as we go. So we need to add up to positive 10. I figured it out already. 8 and 1's not going to work because 8 times 3 is 24. That's too big. And then if you put the 3 with the 1, that's not going to work, right? That's just not a good combination there. So let's jump down here. So let's see. 4 times 3 gives me 12x. 2 times 1 gives me 2x. Now let's figure out which one we want to be negative. This needs to add up to positive 10. So I'm going to make that negative. So this would be a -1 here. And this adds up to positive 10x. So now I just need to crisscross. So my answer is going to be 4x minus 1, 2x plus 3. And don't forget about that 11x that we originally took out. I'm just going to quick check this FOIL in my head right here. 8x squared plus 12x minus 2x minus 3. Yep, there we go. So again, there are so many ways to factor trinomials where the leading coefficient is not 1. This, to me, is the most efficient, and it works with big numbers as well. All right, thanks for joining us today. I hope you have a wonderful day.